Question 16. I've got a circle and I've got the line L1 and L2, which are both a tangent to the circle. And I know the y-intercept of the lines L1 and L2. So L1 and L2 can be written y equals mx plus 12. I don't know the gradient, but I do know that the y-intercept is 12. And what I want to do is I want to find the gradient of those lines such that they only touch the circle once. So I want to find the gradient of those lines such that there is only one solution to these two equations solved simultaneously. Okay, so I'm going to solve those equations simultaneously, and then I'm going to restrict them so there is only one solution. How am I going to do that? Well, the discriminant will have to equal 0, but we'll come to that in a second. We know that m, the gradient of those two straight lines, has to be such that the two straight lines are tangential to the circle. Let's start off by solving those equations simultaneously. Right, I'm going to solve them simultaneously. So I'm going to substitute in that expression for y from the top equation into the equation of the circle. So I'm going to have x minus 6 squared plus, not y this time, but mx plus 12 minus 5 squared equals 17. Let's pursue this. That's going to be x minus 6 squared plus mx plus 7 squared equals 17. Right, let's multiply out those brackets. X squared minus 12x plus 36 plus m squared x squared plus 14mx plus 49 equals 17. This is a quadratic equation. Let's set it equal to 0. And as we're setting it equal to 0, let's put all the x squared terms next to each other. So I've got x squared plus m squared x squared. Let's put the x terms next to each other. I've got plus 14mx and minus 12x. And let's sort out those numbers, 36 and 49. 36 plus 49 gives me 85. Now minus 17 from both sides gives me plus 68 equals 0. Now, if I were to solve this equation, I would be finding the points which my line, y equals mx plus 12, has in common with the circle. But I'm going to restrict this because I want there to only be one solution. So I'm going to fix this so that the discriminant is 0, because that will mean there's only one solution. Before I do that, let's just make our coefficients very clear on our x squares and our x's. So here I have got x squared, lots of 1 plus m squared. X's, I've got 14m minus 12 of those, and my last term in the quadratic equation is 68. I want there to only be one solution, which means that b squared minus 4ac has to equal 0. And when I set up that equation and solve it, I will find the values of m, which mean that there is only one solution to that equation. Right, let's do that now. B squared, 14m minus 12 squared minus 4 times a times c. I'm going to write 4 times c times a, since a is a bracket. Just makes it easier. And I need that to equal 0. Okay, so let's multiply out this bracket. 14m minus 12 squared, 196 m squared. Now 12 times 14, and I want to double that. Minus 336 m plus 144. Now I'm going to do minus 4 times 68, so minus 272 times the 1, and minus 272 times the m squared. That has to equal 0. Right, let's simplify that, shall we? I've got 196m squared minus 272m squared gives me minus 76m squared. I've got minus 336m, and I've got 144 minus 272. I've got minus 128. That equals 0. So I'm going to change all the signs on this. 76m squared plus 336m plus 128 equals 0. And I'm going to solve that equation. All right. Now, when I solve that equation, how shall I do that? I'm going to use the formula and work out the solutions to that. Right, so I paused the film just now and I went away and I solved this equation using the formula, and I get my two solutions, which are that m is minus 8 over 19 or minus 4. So that means that my two gradients, which mean that the lines are tangential because they're the two gradients that mean there's only one solution, my two gradients are minus 18 over 19 or minus 4. So the gradient of this line is minus 4, and the gradient of that line is minus, what was it? Minus 8 over 19. Okay, because those are the two gradients, which mean there is only one solution. So they're the two gradients that mean that the lines are tangential to the circle, rather than crossing the circle at 2 points or at no points. Okay. So the question was, write down the equations of L1 and L2. Well, I'll do that over here. So L2, it was y equals mx plus 12. So it is y equals minus 8 over 19x plus 12. And similarly, L1 is now y equals minus 4x plus 12. And that question all hinged upon knowing that because the line was tangential to the circle, there could only be one point where the two met, which means that the discriminant must equal 0. And that's the end of question 16. Question 17. Okay, I've got the points A and B on a circle with a centre of C. I've got A and B with coordinates shown. M is the midpoint of the line segment. So just a minute, I know that that's a right angle. Okay, and the line L passes through M and C. Find an equation for L. To find the equation of a line, I need to know a point on the line, and I need to know its gradient. Well, I know that I've got A at 3, 7, and I've got B at 5, 1, and I know the midpoint of AB, M, is on the line. So I'm going to find the midpoint of A and B by averaging the x-coordinate of A and B and the y-coordinate of A and B. So the point M is 4, 4. So that's a point on my line L. I also need the gradient. Well, the gradient of the line L will be the negative reciprocal of the gradient of AB. So let's work out the gradient of AB. The difference in the y-coordinate, 7 minus 1 over 3 minus 5. 6 over minus 2. So the gradient of AB is minus 3. So my line L has got a point on it, 4, 4, and it has a gradient of a third, the negative reciprocal of minus 3. So I can find that curve now. The gradient of L by doing y minus 4 equals 1/3 of x minus 4, which is going to be 3y minus 12 equals x minus 4. 3y equals x plus 8. Y equals x over 3 plus 8 over 3. And that is the equation for the line L. Okay, part B. Find an equation of the circle. Well, to find the equation of the circle, I need to know its centre and its radius. Now it says, given that the x-coordinate of C is minus 2. Right, well, I know that C lies on the line L, the line I've just found. So if the x-coordinate of C is minus 2, then the y-coordinate is minus 2/3 plus 8/3. That equals 2. So the point C has coordinates minus 2, 2. So now I know the centre of the circle. I just need to know the radius of the circle, and then I can write out its equation. Now the radius of this circle here is the distance between C and A. And I've got the coordinates of C, and I've got the coordinates of A. So I think I can find the radius. C is minus 2, 2. And the coordinates of A are 3, 7. Okay, so that means that the distance AC is going to be the square root of 5 squared, the difference between minus 2 and 3, plus 5 squared, the difference between 7 and 2. So AC, the radius of my circle, is the square root of 50. So the equation of my circle is going to be x plus 2, x minus 2 squared, plus y minus 2 squared equals 50. And that is the equation of the circle, which I'm asked for in part B. Part C, find the area of triangle ABC. Right, well, let's have a look at triangle ABC. I'm going to do part C up here. So I'm going to start by drawing the triangle ABC. ABC, there we go. Now, what do I know about the triangle ABC? Well, AC is the radius of that circle. Sorry, my thing stopped working. Try again. AC here is the radius of the circle. The radius of the circle is root 50. So that's root 50 there and root 50 there. I must find the area of this triangle, so it'd be useful to know its height, which I'll call h. Now, I don't know its height yet, but I could find AB, the length of AB, because I know that A is 3, 7, and I know that B is 5, 1, which means that the length of AB is the square root of 2 squared plus 6 squared, which is the square root of 40. So AB is the square root of 40. So finding the height of this triangle then, the height of the triangle is going to be the square root of the root 50 squared minus root 40 over 2, that's the length of the base of my right angle triangle, squared. Okay, now that is the square root of 40 with a bit of calculator use. So the height of my triangle is the square root of 40. So the area of the triangle is the base, root 40, times the height, root 40 over 2, which is 40 divided by 2, which is, of course, 20. And that is question 17 sorted. Okay, question 18. So I've got a circle, and I'm told its equation. Okay, so that means that I know the centre of the circle already. So the centre of the circle is 3 minus 3. I'm told the radius of the circle is 52, and the baselines are tangents and have a gradient of 3 halves. Okay, find the points of intersection P and Q of the tangents and the circle. Okay, so I'm being asked to find these 2 points here. Well, what I'm going to do is I'm going to start off by finding the equation of that line. Because once I've got the equation of the line, then I'll be looking for points which are on the line and on the circle. So I'll be able to set up some simultaneous equations. So that's how I'm going to do the question. Let's get on with it. To find the equation of this line, which I'll call L3, I need a point on the line. Well, I've got that because I know that the centre of the circle is at 3 minus 3, and I need the gradient of the line. Well, I've got that because I know that the gradient of those tangents is 3 over 2. So the gradient of my line is minus 2 over 3. And now I can simply use y plus 3 equals minus 2/3 x minus 3. And simplify this. 3y plus 9 equals minus 2x plus 6. 3y is minus 2x minus 3. Y is minus 2/3 of x minus 1. So now I've got the equation of L3, and I'm simply going to find points which are on L3 and on the circle. So, to find points which lie on L3 and on the circle, I'm going to need to solve the two equations simultaneously. That's the equation of L3 and the equation of the circle. How am I going to do that? Well, what I'm going to do is I'm going to take this expression for y and substitute it into this equation. So I'm going to have x minus 3 squared plus, put this in a bigger bracket, y, which is 2/3 x minus 1, plus 3 squared equals 52. So that's going to give me x minus 3 squared plus minus 2/3 of x plus 2 squared equals 52. Now I've got an equation in x here, so I can solve this. X minus 3 squared is x squared minus 6x plus 9 plus, right, minus 2/3 of x plus 2 squared. Minus 2/3 of x times minus 2/3 of x is going to be 4/9 of x squared. Then my middle term is going to be minus 4/3 x. I'm going to have an outer term of minus 4/3 x. So I get minus 8/3 of x plus 4 equals 52. Okay, right, let's multiply everything by 9. Get rid of those fractions. 9x squared minus 54x plus 81 plus 4x squared minus 24x plus 9 fours are 36 equals 52. No, it doesn't equal 52. I have to multiply that 52 by 9 as well, of course. Equals 468. Okay, now this is a quadratic equation. Let's set it equal to 0 and see if we can't factorise. Tidy up the left-hand side. 13x squared minus 54x minus 24x minus 78x. And then for my numbers here, I've got 81 plus 36. And from that, I'm going to minus 468 to bring that 468 onto the left-hand side and set my equation equal to 0. Right, I need to factorise that. I bet 13 will go to everything. 13x squared minus 6x minus 351 divided by 13 is 27. Still factorising. 13. Put this into two brackets. I'm going to have an x and an x. I've got to have a plus and a minus, haven't I? Multiply to add to minus 6. 9 and 3. There we are. So my two solutions for x here are that x equals minus 3 or x equals plus 9. Now I need to find the y coordinates of those points of intersection, and I know that y is minus 2/3 x minus 1. So if x is minus 3, then y is minus 2/3 of that, which is 2, take away 1, which is 1. Or if y is 9, then it's minus 6, take away 1 is minus 7. So my 2 points are the point minus 3, 1, and the point 9, minus 7. Let's just see if that looks okay. That looks right on the diagram, and that is 18a finished. Right, part B. We've got to find the equation of the lines L1 and L2, giving our answers in this form, ax plus by plus c equals 0. Okay. Now, to find the equation of a line, I need to know a point on the line and the line's gradient. Well, this is the line L1, and this point here, minus 3, 1, is on L1. And similarly, the point 9 minus 7 is on L2. So I know a point on each of the lines, and I also know the line's gradients. So that means I can get on and write down their equations. So let's do L1 first. L1, my point on the line is minus 3, 1, and the gradient of the line is 3 over 2. I'm going to use y minus y1 equals mx minus x1. Right, let's multiply everything by 2. Multiply out the bracket. Now I wanted all the x's on one side, so I'm going to keep them here. 3x, take away the 2y, add 2 to both sides, plus 11 equals 0. So my answer is 3x minus 2y plus 11 equals 0. And what about L2? Well, L2, my point on the line is 9 minus 7, and the gradient is 3 over 2. Okay, so y minus y1 equals 3 over 2, x minus 9. Double everything, multiply out the bracket. Let's put everything on the right hand side. 3x minus 2y minus, what's that, 41 equals 0. So my equation is 3x minus 2y minus 41 equals 0. And that is finished. Question 19. Okay, I've got a circle, and I've got 2 tangents to the circle. The tangents to the circle have got a y-intercept of 6, and I don't know their gradient. So the tangents to the circle have an equation y equals mx plus 6. Okay, and I know that the line and the circle has just one point in common because the line is tangential to the circle. So I've got the equation of the circle here, and I'm going to solve these 2 equations simultaneously and then specify that there should only be one solution. Right, I'm going to substitute in the value for y into the equation of the circle. So I'm going to have x squared plus 6x plus y squared, which is mx plus 6 squared, minus 2 lots of y equals 7. Okay, right, I'm going to multiply that out now. So I've got x squared plus 6x. Now I'm going to square mx plus 6. Gives me m squared x squared plus 12mx plus 36. Multiply out this bracket. 2 lots of mx minus 12 equals 7. Good. Okay, let's tidy up what I've got here. Put all the x squareds together. So I've got an x squared plus m squared x squared. I've got some x's. I've got 6 x's and another 10m x's. And I've got 36 minus 12, and then take away 7 from both sides. Leaves me with plus 17. There we go. There's my equation. It's a quadratic equation, and I know that I only wanted to have one solution, so I'm going to set that discriminant to equal 0. Before I do that, let's make very sure that I know what the coefficients are of the x squared, 1 plus m squared, x squared, that, plus, what's the coefficient of the x? 6 plus 10m, and then my c term is 17. Now I know the discriminant must equal 0 because there's only one solution. So b squared, that's b squared, minus 4 times a times c. 4 times c times a. And I know that that should equal 0 because there's only one solution. So I'm going to simplify that now. So what I've got here is I've got 6 plus 10m squared minus 4 17s are 68 times 1 plus m squared, and that equals 0. Right, let's multiply out this bracket now. 36 plus 120m plus 100m squared minus 68 minus 68m squared equals 0. Right, to tally that up, I'm going to have 32m squared plus 120m minus 32 equals 0. Now I need to solve that equation to find out what m will be. I use the formula, and having used the formula, I have the solutions that m is a quarter or m is minus 4. So that tells me what my two lines are. Here's the diagram showing the two lines. One of those, the line L1, will have a gradient of minus 4. So that's y equals minus 4x plus 6. And the other one, L2, must have a gradient of a quarter. So that will be a quarter x plus 6. And that is my answer to part A. Okay, part B. Let's just remember where we were. I've got a circle here, and I've got two lines, L1 and L2, which are both tangential to the circle, and I've just worked out the equation of L1 and the equation of L2. Now in part B, I'm asked to find the points of intersection, P and Q. So let's do Q first. Q is where L1 and my circle here intersect. So I'm going to solve those equations simultaneously. So I'm simply going to substitute in this expression for y in the equation of the circle. The equation of the circle is x squared plus 6x plus y squared minus twice y. And that equals 7. Okay, so I'm simply going to solve this equation slowly and steadily. Right, I've got to square minus 4x plus 6. It's going to give me 16x squared minus 48x plus 36. Right, minus 2 times the bracket. That's going to give me plus 8x minus 12 equals 7. Okay, now I need to tidy that up now. So how many x squares have I got there? 17x squared. What about the x's? I've got minus 32x's plus 8. Got minus 42x's plus 8 is minus 34x's. And then I've got plus 36 minus 12 gives me 24. Take away 7 gives me plus 17. Okay, let's see if we can't solve this equation. X squared minus 2x plus 1. Look at that. 17 x minus 1 times x minus 1. There's only one solution. Well, we knew there was. And that is when x equals 1. And when x equals 1, y is minus 4 times 1 plus 6. So y is 2. So the point P, which one is that? The point Q, that is. The point Q is going to be at 1, 2. Okay, now I'm going to find the point P. Right, to find the point P now, I'm going to solve the equation of L2 simultaneously with the equation of the circle. So this time I've got this expression for y, and I'm going to substitute that into the equation of the circle. X squared plus 6x plus y squared, so that's a quarter x plus 6 squared minus 2y twice a quarter x plus 6 equals 7. Right, x squared plus 6x plus, right, I've got to multiply out a quarter x plus 6 squared, so that's going to give me a 16th of x squared. Now I'm going to have 6 quarters doubled 12 quarters, so that's 3x plus 36 minus 2 times a quarter, that's minus a half of x, minus 12 equals 7. Okay, tidy that up then. Actually, before I tidy it up, let's multiply everything by 16, make it a bit easier for ourselves. So 16x squared plus 6 times 16, 96x plus x squared plus 48x plus 16 times 36, 576 minus 8x minus 16 times 12, 192 equals 7 times 16, 112. Now let's tidy it up. 17x squareds. Okay, x's. I've got 136 x's. Okay, now I've got 576 minus 192 minus 112 to bring that onto this left-hand side gives me my quadratic set equal to 0. I've got to factorise that now. Well, 17 goes into everything, fortunately. 17 is x squared plus 8x plus 16. Can I factorise it further? Yes, I can. X plus 4. Lots of x plus 4. Well, I did know there would only be one solution, and the solution is when x is minus 4. And if x is minus 4, then y is a quarter of that, plus 6. So y must be 5. So my point here is minus 4, 5. And that is part B finished. Right, part C. Let's have a quick recap as to where we are. We've got a circle, and we've got the coordinates of point P here, and the coordinates of point Q here. And in part C, we're asked to find the area of the quadrilateral A, which is the centre of the circle. Okay, A, P, R, Q. So Q is minus 4, 5. R up here is 0, 6. P is 1, 2. Now, what are the coordinates of A here? Well, that's the centre of the circle. So just looking at the equation of the circle here and sort of completing the square in my head, I can see that I would have x plus 3 squared. So A has an x coordinate of minus 3 and a y coordinate of 1. Okay, so I've got to find the area of that quadrilateral there. Well, it's a kite. The area of a kite is the length of the diagonals multiplied by each other divided by 2. The product, half the product of the length of the diagonals. So let's have a think about the length of these diagonals. I've got A to R, haven't I? Well, A is minus 3, 1, and R is 0, 6. So the length of that diagonal there is going to be the square root of 3 squared plus 5 squared, which is the square root of 9 and 25 square root of 34. Okay, and I've also got PQ. Well, that's 1, 2, and minus 4, 5, which is going to give me a length of 5 squared plus 3 squared, which is the square root of 34, just like it was on the left-hand side. So the area of that kite is going to be the square root of 34 multiplied by the square root of 34 over 2. 34 over 2, which gives me an answer of 70. And that is question 19 complete. Question 20. Right, I've got a circle. I know its centre, and I know its radius, so I know its equation. And I've got a line L1 with this equation here, and I need to find the points where L1 intersects the circle. So for part A, I've got the equation x plus y minus 21 equals 0, and I've also got the equation of the circle x minus 6 squared plus y minus 9 squared equals 50. I need to solve those simultaneously. But I'm going to use that top equation, and I'm going to get an expression for x. X would be 21 minus y, and then I'm going to substitute that into the equation of the circle. So instead of x minus 6, I'm going to have 21 minus y minus 6 squared plus y minus 9 squared equals 50. And I'm going to solve this equation for y. So I get 15 minus y squared plus y minus 9 squared equals 50. Right, multiply out that bracket. 225 minus 30y plus y squared plus, multiply out this bracket, y squared minus 18y plus 81 equals 50. Okay, I'm going to collect together all my y squareds, all my y's. So I've got 2y squared. I've got minus 48y. Now when it comes to the numbers, I've got 225 plus 81, and then I'm going to minus 50 from both sides, which leaves me with plus 256 equals 0. Now I've set my quadratic equal to 0. I'm going to factorise it. Start by taking out a 2. 2 lots of y squared minus 24y plus 128. And now I need to factorise that. Y and y. It's going to have a minus and a minus. Multiply to 28 and add to 24, 16 and 8. Good. So my solutions are that y equals 16 or y equals 8. Now each of those, of course, will have a corresponding value of x. I'm going to use this equation here. X is 21 minus y. So if y is 16, then x is 5. And if y is 8, then x is 21 minus 8, 13. So my 2 points here, they were the points P and Q. P has the lesser of the x coordinates, so P will be 5, 16, and Q will be 13, 8. And that is part A complete. 20 part B. Right, let's just recap. I've got a straight line, L1, which is here. I've got the points P and Q, which I found here, which is where L1 intercepts the circle. And here is the equation of the circle, which has a centre of 6, 9. And a radius of root 50. Right, I've got to find the equations of L1 and L2. Okay, well, let's have a look at, sorry, I've got to find the equations of L2 and L3. Let's have a look at L2 first of all, shall we? Now, L2, I know that L2 goes through P, so that's going to be useful because in order to write down the equation of the line, I need a point it goes through, and I also need its gradient. How am I going to find the gradient of this line L2? Well, the answer is it's a negative reciprocal of the radius at that point. How can I find the gradient of the radius? Well, I know the point P, and I know the point A as well. I know the centre of the circle. Look, so I'm going to write A here, which is the centre of the circle, 6, 9. I'm going to find the gradient of AP and use that to find the gradient of the line L2. The gradient of AP is going to be minus 7 over 1, which is minus 7. Okay, so that means that the gradient of L2 is going to be a 7th, and I know that L2 goes through the point P. There you go, I've got what I need to write down the equation of L2 now. Y minus 16 equals 1/7 of x minus 5. So multiply everything by 7. 7y minus 112 equals x minus 5. 7y equals x plus 107. So y is x over 7 plus 107 over 7. And that is the equation of L2. Okay, now I'm going to use a similar method to find the equation of L1. So let's do L3. Let's do L3 up here. Now L3 goes through the point Q. So let's write down those coordinates, 13, 8. And I'm going to use the gradient of the radius here, that's the gradient of AQ. So let's write down A. I'm going to use the gradient of that radius to help me find the gradient of L3. So what is the gradient of this radius here? What is the gradient of QA? Let's have a look. Well, looking at the y coordinates, that's 9 to 8 is minus 7, and 6 to 13, sorry, 9 to 8 is minus 1, and 6 to 13 is 7, so the gradient of QA is minus a seventh. So if I'm looking at L3, the gradient of L3 will be the negative reciprocal of that, and I know that L3 goes through the point Q. So now I can write down the equation of the line L3. Okay, so I've got y minus 8 equals 7x minus 91, so y equals 7x minus 83, and that is the equation of L3. So there you are, I've worked out the equation of L2 and the equation of L3, and that's part B done. Part C, find the equation of L4, the perpendicular bisector of the chord PQ. Okay, right, well I've got P, which is 516, and I've got Q, which is 13.8, and I'm being asked to find the equation of the perpendicular bisector. Well, clearly it's going to go through the midpoint. So the midpoint here will be the average of the x coordinates, 9, and the average of the y coordinates, 12. And the gradient of my perpendicular bisector, well, the gradient of P to Q is, let's see, minus 8, 16 to 8, and then plus 8. So minus 8 over 8 is minus 1. So the gradient of my perpendicular bisector is going to be 1. So I'm going to write down the equation of a line which goes through the point 9, 12 and has a gradient of 1. Y minus 12 equals 1, x minus 9. Y minus 12 equals x minus 9. Add 12 to both sides. Y equals x plus 3. So that is the equation of L4, the perpendicular bisector of PQ. Okay, part D. Show that the two tangents, well, that's L2 and L3, so those are those two lines, and the perpendicular bisector, that's that equation, intersect, and find the coordinates of R, the point of intersection. So I've got to show that these intersect first of all. Well, let's solve L3 and L4 together and see where these two lines intersect. And once we've done that, let's show that that point is also on this line, L2. Right, so it's going to give me 6x equals 86. So x equals 86 over 6, which is 43 over 3. And y will be 43 over 3 plus 3, 52 over 3. So my two lines L3 and L4 intersect at the point 43 over 3, 52 over 3. And if I'm going to show that all three lines intersect, I simply have to show that this point is also on the line L2. Well, here is L2. L2 is y equals x over 7 plus 107 over 7. So if I take x to be 43 over 3, then y apparently should be 43 over 3 divided by 7 plus 107 divided by 7. Right, 43 over 3 divided by 7 plus 107 over 7. And lo and behold, that equals 52 over 3, as we hoped it would, 52 over 3. So I've shown that the three lines intersect, and I've shown that the point of intersection is 43 over 3, 52 over 3. And so I found the coordinates of R. Okay, part E, calculate the area of the kite, APRQ. Right, well, let's have a look at that then. So A, P, R, Q. There we are, not a great diagram. A, P, R, Q. Now I know the coordinates of P, 516. I know the coordinates of Q, 13,8. I know the coordinates of R, because I've just worked them out. And I know the coordinates of A, because that's the centre of the circle, 6,9. So how am I going to find the area of the kite? Well, as you probably know, to find the area of a kite, you can do the product of the diagonals and then divide by 2. So what I have to do here is I have to find the length of the two diagonals, multiply them together and divide by 2. Right, well, the length of PQ is going to be the square root of 13 and 5 gives me 8 squared, plus 8 to 16 gives me 8 squared, plus, right, the distance AR is going to be the square root of 43 over 3 minus 6 squared plus 52 over 3 minus 9 squared. Okay, good. So that is the distance of one. The length of one, I'm supposed to be multiplying by the length of the other, and then dividing that by 2. And if you put all that into your calculator, you will get the answer 200 over 3. And that is the last part of the question. It's been a bit of a marathon. Well done.